Okay, just really quickly, I want to talk about how this relates to even something we already know about mixed numbers. So today I had a class and they were doing this problem. 2 1/5 times, I don't know, I'm making it up. It was similar to this, 3 1/3. And so they said, well, couldn't I just multiply the 2 by the 3 and the fraction times the fraction? Wouldn't that work? That would be 6 1/15. Is that right? Okay, but we can come back to this idea of geometry, okay, in terms of the square. Because when I'm multiplying, really, I'm talking about square units all of a sudden. So 2 and 3, and then just this fraction over here of 1/5. So an addition, or sorry, a multiplication problem of fractions involves addition, right? If I have 2 1/5, when I say the word and, it's like I have 2 plus 1/5. You see there's an implied addition there. And then here, this is 1/3, and it's really the same thing as 3 plus 1/3. So the area here is 6. The area of this tiny little piece over here is 1/5 times 1/3, which is 1/15. Okay, but the area over here is actually this length, which is 3 times 1/5. You see that? So this is 3 times 1/5. And this section here would be the same thing as 2 times 1/3. 2 is the length, 1/3 is the width, so this would be 2 times 1/3. So you see why it's a little bit more complicated than that. Everything has to get distributed to everything else, which is the reason why we FOIL. And we always want to FOIL when we have this addition in between because of these extra spaces here. Does that kind of help? Yes. So essentially, which is the reason why, when it comes to mixed numbers, I always tell students, well, just make this into an improper fraction, make this into an improper fraction. Then you don't have to worry about all the distribution that would have to go on. You see, because I don't really want you to have to make it more complicated, but I was just thinking if it came to only numbers, maybe that would help you see, you know what I mean?